Welcome to experiment 6. So in this experiment, we are going to compare three popular machine learning algorithms for an NLP task called sentiment analysis. Sentiment analysis simply means reading a piece of text and deciding whether it is positive or negative. For example, if there is a sentence like I love this product, it is the positive sentiment, right? And if you take a sentence this is terrible, it is negative. So the three algorithms we are comparing are naive Bayes, SBM, and random forest. So our goal is to train all these on the same data, test them, and find out which one performs best. So while coming to the code, the first step is importing the libraries. We import vectorizer, which converts text into numbers. Then train test splits. As we know, the splits are data into training and testing portions. Then we import the three models, multinomial NB, which is for naive Bayes, SPC for support vector mission, and random forest classifier. Finally, we import accuracy score and classification report to measure how well each model performs. So running the cell just loads all the tools, no computations happens here. So while coming to the next step, this step is creating our data set. We have 15 positive sentences like I love this movie, amazing experience, outstanding product. So these are labeled as 1, which means positive. Then we have 15 negative sentences, things like this product is very bad, worst experience ever, absolutely terrible. This is labeled as 0, which simply means negative. So then we combine both the list into a single list called text, and the corresponding labels go into a list called labels. Then now we have 15 ones followed by 15 zeros, which means 15 positive and 15 negative. So why we taken 30 samples? So because the original experiment had only 8 samples, which is too small for a model to learn meaningful patterns. More data means more accuracy, right? Okay. So while coming to the next step, converting text into numbers using TF-IDF. Machine learning models cannot understand words. Simply, they can't understand words. So we must convert them into the numbers first. TF-IDF stands for term frequency inverse document frequency. So in simple words, we can say it as it gives a high score to the words that are important and unique to a sentence, and a low score to the common words like is, the, these are articles and prepositions, right? So these words have low score. So notice we pass n-gram underscore range equal to 1 comma 2. What does this means is we capture both individual words and pair of words. So what we call as bigrams. So the phrase very bad is treated as a single feature. So this is important because not good means negative. But if we look only at not or good separately, the model gets confused. So then we call fit underscore transform. This first learns the vocabulary from all our sentences, then converts each sentence into a row of numbers. The output shape tells us we have 30 sentences and the number of unique word features. After that, we are splitting our data set. Okay. Um, we use train test splits with the test size 0.2, which means 80% of data goes to the training and 20% of the data kept aside for testing. So random state equal to 42 ensures we get the same split every time we run the code. So this important parameter here is stratify equal to labels. This guarantees that both the training set and the testing set have the equal proportion of positive and negative samples. So without this, you might end up with all positive in the training and all negative in the testing. So which would give a misleading results. So out of 30 samples, 24 go to training and 6 go to the testing. So after that, we are coming to the step 5. Here, step 5 is the main part, training and evaluating all the three models. So we define a dictionary called models with the entries. Naive Bayes, SVM with linear kernel, and random forest with 100 trees. Then we loop through each model. So for every model, we do three things. First, model.fit. We train it on the training data. Second, model.predict. We use it to predict labels for the test data. Third, accuracy score. We compare predictions to actual labels and calculate accuracy. So we also print a classification report which shows precision, recall, FN score, and support. Okay. So now let me explain this quickly. So precision means out of all the times the model predicted positive, how many were actually positive. Recall means out of all actual positive sentences, how many did the model correctly identify? Then FN score is the balanced combination of the both. So now let's look at the output. Naive Bayes gives around 83% accuracy. Random Forest also gives similar results, but SVM got 100% accuracy on this dataset. Why does SVM perform best? Because the text data in TF-IDF form is high dimensional and SVM is linear kernel and specifically designed to find the best separated boundary in high dimensional spaces. So it handles text classification extremely well. Okay. So now we are going to compare and find the best model, which is the step 6. Okay. So we print a clean accuracy comparison table using the results dictionary. We use Python's built-in max function with key equal to results.get to automatically find the model with highest accuracy. In our case, SVM is identified as the best model with 100% accuracy.